All right, good morning. Last day of Cisco Live already. Appreciate that you all come in at that early time after the party. Must have been good, but you're really dedicated to technology, to your job, and maybe to me, I don't know. Maybe not as attached, but thanks for coming by. Today, we're going to go in a day in the life of a packet in a VXLAN BGP EVPN fabric. So single fabric, and then after that separate session, we have the same kind of topic, day in the life of a packet for a multi-site setup with VXLAN EVPN. I think it's an hour after we are done here together, and Max will present that piece. I feel the current session is at what we call a 2000 level, an intermediate level. It's classified. I would believe it's more of a 3000 session, advanced session. I have a lot of slides in there for your reference where you can go forth and back and look at this. And with this, I'm just jumping in there. My name is Lucas Kradiger, and we will have a roller coaster ride this morning, so let's have fun. WebEx Teams or WebEx app, you have the option to subscribe there and ask questions. I think yesterday I got a couple of you guys asking questions in the multi-site session. We answered most of them. The PDF I will put into that room as well. I forgot this morning, it was too early. And also ask questions if needed. We will try to answer them during the session. Max is sitting over there and typing, or we will do it after the session otherwise. Abstract. Nothing else than a packet walk. And it's not one packet walk, it's actually we're going into multiple packet walks. But to give you again a little bit of an intro, I have to cover how things are working in some kind of way, and I'm going through that beginning. Packet walk will be routed, bridged. We will do BUM, broadcast down on unicast and multicast, and we will do silent host discovery. And all of this will be like 10, 20 slides instead of one slide with a lot of automation. So your PDF should actually give you every single step, which I click through here, exactly the same way. The week is going towards an end. You are here at the yellow spot at 8 a.m. on a Thursday morning. I always want to say Friday morning, Thursday morning. And then after that, we go into the multi-site, and then there's some streaming telemetry and elastic services redirection, which will come up. Agenda, and as said, it's all about packet walks with a little bit of an introduction. And what is VXLAN? You guys know what VXLAN is, right? Can we stop that here? It's an encapsulation, it's data plane. What is EVPN? It's a control plane, BGP-based. Routing and bridging, as well as BUM handling, is managed there. So this, so far, to the intro, and then the dating network. You guys probably saw that twice or three times this week. It's all about the dating network where the control plane meets the data plane. Because we have a data plane that encapsulates, and the control plane tells the data plane what to do. If there's no control plane, there is nothing to do, right? We're just taking a nap a couple of more seconds. The other thing I was told earlier, I'm not allowed to do stage diving. So I will stay up here, right up there. I will not go there, and I will not go into, jump into the audience. But with this network device up here, network device in a fabric has a host attached. We have a network side, the spine attached there in this case. We have an uplink, we have a downlink. The downlink or the host side or the access side is the green part. The right side, the fabric side, the core side or the uplink, the right part. The blue part is purely routed. The green part here would be a layer 2 attached, like a trunk or an access port in the most likely scenarios. Now, the network device has to become a little bit special, so we give them a VTAP, and when it becomes a VTAP, a VXLAN tunnel encapsulation or VXLAN tunnel endpoint, it becomes a network virtualization edge. So it's at the edge like me over here, tilting towards the host doing one thing, tilting towards the network doing another thing, meaning originating the tunnel going into the network side. But it is still a router, it's still a switch, or a router or a switch. It is still a network device, and or still an edge device in the general terminology there. We have tables on these NVs, network virtualization edge, or VTAPs, or leaves, or borders, or whatever you want to call them there. And generally, there are 3 tables of relevance on a leaf, or on a host-facing VTAP or NVE. You have a MAC table for learning layer 2 information. You have an ARP table for binding MAC to IP. Could also be ND. I just take the V4 part here as it gets a little bit simpler. And then we have a RIP and a FIP. RIP is the software part of the routing table, and FIP is the hardware part of the routing table. And if they're not consistent, Houston, we have a problem, okay? So as I turn on the host, I will learn automatically, like every switch would, the MAC address, right? Traditional MAC learning, local learning. ARP, we will learn ARP when the host ARPs, so we will learn the neighbor discovery information when IPv6 ND is enabled. So that's where we get the binding between MAC and IP, the VLAN, the VRF participation only because we have an IP, right? And then subsequent there, we will also install that host route information out of the MAC and IP binding in the RIP-FIP as a host route, as a /32, mark it local, and given that we have a VRF association of an SVI, which is an interface VLAN, we will have a MAC IP binding, the IP sits in the VRF, so we know of all of these different information. When we do this, when we learn this, we do send an advertisement. We send a BGP advertisement because EVPN is part of BGP, or is a BGP address family. So we send that to another leaf directly, or we send it to our route reflector. And in my topologies here, the route reflector sits on my spine, and I don't know the other leaves specifically, so I just send it to the route reflector, and he will take care on the rest. If it is a subnet, if there is an SVI on a switch, we'll always advertise first a route type 5 with the subnet, with the interface VLAN where the host sits in. And that happens actually before the host even is activated. And you see here, there is a type 5, and oh, sorry about that. I'm completely messed that up. Actually, this is a route which comes from external. Apologize. I will come back to that route in a second. Give me, okay. Let me recap that. When I get something from outside, from somewhere else, from another VTAP, I get a route advertisement from my route reflector and then respectively receive it on the NV. In this case, I say I want to learn, or I learn a route type 5, which is an IP prefix route. Right, 5 has always this subnet capability, and it will then install this subnet somewhere into the table, and given that's a type 5, we don't have MAC addresses there. Right? We don't have host IPs there. We actually have a subnet route, /24 in this case, and we will import that on that RIP-FIP part 10.10.10.0.24 with a next hop of 1112, which came all from the control plane. So remember what I said, it's a dating network, right? As I learn control plane information, I will be able to use this control plane information to make a decision on what to do, like forwarding. And this is basically how we construct out of a routes received. In this case, it's a route type 5 prefix route. This is how we afterwards construct, I don't have a laser here, the construct on how we built the route towards something in the 10.10.10.0 subnet, in that case 10.10.10.77. Yeah. I had that slide somewhere else before, so it's never good to rearrange things in the morning of a presentation. This here is remote learning of a host. So you saw before remote learning of a subnet, somebody advertises this, and this here is the remote learning of a host. You see this is now a route type 2. EVPN route type 2 is a MAC IP route. So we always have a MAC address portion, it's mandatory, and you have an IP portion which is optional. Why? Because there could be a non-IP host in my network, right? Or a host that didn't ARP at that point. So in this case here, route type 2, we have a MAC, we have an IP, we have 2 labels. Label 1 is for layer 2, label 2 is for layer 3, meaning 1 is the part where we put the bridging information in, and the other one is where we put the routing information in. And the route target 2 is respectively related to label 1, label 2. So label 1 for bridging, it's route target 1. Label 2 for routing, it is route target 2. Next up is there, and whenever I need to route, there is some router MAC story going on because VXLAN is a layer 2 encapsulation, so we always have an inner MAC header. We need to fulfill the obligation to complete that inner MAC header. So this is basically the destination MAC of my remote VTAP of who has the next hop IP address. And That's just simply that we don't have to go and ARP for these guys. Who wants to ARP for every router in a big network? Give me the information in the control plane, I program it, I'm done. So we reduce flooding in flooding in core-facing networks. Now, when I learned this, I go and import that, and you see here I import it in 2 places. I import it as for one in the MAC table with route target 1, with VLAN 10, which is in my case the 30,001 label. So we have up there the bridging information imported, and I will take the routing portion of that, so the IP portion of that host route, MAC IP route type 2, and put it into the RIP FIP, right? So no magic, bridging goes in MAC, routing goes in RIP, more or less. Now here, bridging case, if I want to talk to that remote host or to a remote host for any case, I take again the information I learned for creating all the destination attributes like the DIP, the destination IP of my remote VTAP there. I have the destination MAC who I want to reach. I have the destination IP of the host itself I want to reach, and this is being constructed here in this respective case. That was intro. You guys know all of this, right? I think I presented this about two times this week already, and we can go through that again after the session if you guys are okay. Now, I gave you that intro with one reason. I will continue now in a similar fashion, giving you packet walks. It will look about the same. And I will start with layer 3. And the reason why I start with layer 3 is, we just looked at layer 3, so we do nothing else than a repetition. So maybe we don't have to recap the whole intro part after the session, but let's see how it goes. I will always use this topology. I have 4 leaves, a border leaf, 1 spine, and I have a whole bunch of hosts connected to. I have the green hosts, which are all in the same layer 2 segments, and all the yellow hosts are in the same layer 2 segment, and all of them are in the same VRF. So we will not do leaking between VRFs. We will focusing on same subnet forwarding, bridging, or MAC-based or IP-based, and we will look at different subnet forwarding, which is basically what routing is. For this first section, we will go from external network to host B or host B to external network. And I will guide you through step by step what is happening in each direction from a learning perspective and from a table perspective, and then ultimately the packet construction forwarding. By the way, this is external world communication. I had a whole session on this earlier this week. So if you want to go dive in all of these scenarios, how you attach that to the external world, it's a good point of looking at these slides. And I think I have a reference here as we go through which session that was. So here you see on the far end my external network. It's 10.10.0. It has some IP next hop outside. So let's say there's a router somewhere. And that IP next hop of 192.168, what is it again? I can't read it. 0.2/30 is my next hop router IP, and then I have the facing the border IP, which is the 0.1/30. That one is in VRF-A. That's our VRF which we are going to use. We use a sub interface, so we have an NCAP sitting there, and you see there I use the sub interface of 1.1.11 because the sub interface ID has nothing to do with the .1q NCAP I'm using up there. So as I have that relationship with that external router, I need the VRF to be consistently configured with the same VNI, with the same route target. Otherwise, I will not learn that external route which I will get on border 1 and then ultimately on leaf 2. So I need to have them configured, and as it's configured and as the external router sends me that prefix route of 10.10.10.0/24, that will result on the border in a route type 5 advertisement. Why it's a route type 5? Because the prefix route, it's externally learned. We send that to the route reflector. The route reflector reflects it to all the leaves which have that respective VRF configured, and it will hit ultimately in this case L2, which is leaf 2. In the route type 5, you see the prefix, you see the label, you see the route target. There's only one because we just do routing. You see the next hop, and you see the router MAC address. Now, as we learn this, we can install this route. If the VRF is configured, in our case it is, we go and install that based on route target, and that means that in my routing table, in my RIP, and then ultimately in my FIP, I have an entry, which is 10.10.10.0/24 with a next hop IP address of B1, which is my exit point from who I received it, and I use the VNI 50,000 because 50,000 was the VNI which was given to me in the VRF configuration as well as in the route from an EVPN perspective. So great, external route learned. Now we have to learn about the host here. Otherwise we can just receive, and we only can send traffic, but we cannot receive traffic, right? I mean, external world doesn't know about host B yet. So host B, Ethernet 1.1, here connected to a trunk, it's doing VLAN 10, trunk, .1Q encapsulated layer 2 port, and we have to have a VLAN definition on this. We need to learn that host, right? We need to learn the IP MAC binding of that host. So I have a VLAN, I have a VNI map to that, VLAN 10, 30,001 is the VNI. I have a route target assigned to this. The gateway MAC address is the Anycast gateway MAC address, so it's first hop gateway for the host, and you see the SVI IP is 192.168.1.1. So this is basically what you configure to attach a host that you can ultimately do bridging and routing out of that host. This is the first hop gateway, the default gateway, or whatever you want to call it. Now when we do this, and here I want to wrap up on that thing which I said before, whenever we configure an SVI, it is a good practice to advertise a route type 5 with the subnet route of that SVI. Why? I tell you towards the end. It's a good practice when you use our NDFC or DCNM, we always do it. One is silent host discovery, which is later in the presentation. The other piece is actually for subnet advertisement towards the external world. Maybe you don't want to advertise host IPs or host routes to the external world on only the subnet. In this case, you get the subnet, which is actually active on switches, and you don't have to deal with a lot of this there anymore. So you see here the routing table as we receive it on border 1. Next hop is L2 because that's the one who sent it. And we then subsequently also send a route type 2, given the host was learned from a MAC layer perspective, the host was learned from an ARP perspective, and you see there 192.168.122/32, 100B, the MAC address of this host. So in this case, B1 will also have a host route entry next to the subnet entry. Why? Because we want to do efficient forwarding. We want to forward it exactly where the host sits. We don't want to do hairpinning. We don't want to do tromboning. So subnet route from all the leaves is not enough to reach the host. You might go to the wrong leaf at that point if there are multiples hosting that subnet. Anyway, that is the learning part. This will be the forwarding tables, how it looks across the network, and as we progress from an encapsulation and routing perspective, host B to external world, this is how the packet is going to be encapsulated, made ready, based on the control plane information we had before. You see source MAC, destination MAC is the default gateway. That means, hey, we need to route, right? If DMAC is default, is gateway MAC, we do this. We go into a routing process. You see L2 IP is the VTAP IP of L2. The DIP is border 1 IP, it's B1. And then you see the VNI, the layer 2 router MAC, the border router MAC, which is the inner VXLAN MAC header, which we need to obligate, and then source IP, destination IP, all the way to the end. There was a question. Yes?
When the DIP receives the type 2 route, the type 2 route also includes a router MAC. Where is that router MAC installed?
Yes, yes. Okay, so the question is, where's the router MAC installed? It's in the ARP table installed towards the remote VTAP. So we know which next hop IP has what MAC address, so it's in the local adjacency table of the switch. It's nothing you will actively see when you do a show ARP table or something like that. It's hidden.
It's related to the RIP table.
It's related to the RIP table. Every next hop in a routing table has a MAC address. So same thing happens here, yeah. This is the reverse one, external word to host B. Same thing happens, just in a different direction. So you flip over the IP address SIP and DIP, respectively the outer SIP and DIP when it comes from border to L2, and then finally as a normal Ethernet frame or IP packet going from L2 to host B. And this was what the reference is. If you want to go into more detail on that piece, there was a whole session on that. Now, given we did a layer 3 packet walk, this is exactly the same. Now it's just host to host. It's L1 to L4. We have again the learning part. So we have a learning on the L4 for host F. There's an Ethernet interface. We do ARP and all of that jebang. So we learn the host locally. Similarly, we advertise the type 5 for the subnet route. And then we learn that subnet route on leaf 1. Given we always want to have that, you will see it in silent host discovery. And then the route type 2 with the host IP address learned out of ARP or ND. And it will complete the table state, the routing table state on L1 for VRF and for MAC in that case. Similarly, when we do host A, we will learn a port, we'll do the advertisement, 5 first, because it's a different subnet. We learn that in the VRF table, 2 for the host itself, and then we have the host as well as the subnet learned, and this is how the tables look like at the point when the advertisement happened, the learning happened, the installing happened. So these are the forwarding tables. You see here, VRF A has a host route for 266 and 20. L4 has also a VRF A for 10 and what is the other one? 112 or 11? It's 11, I guess. 11. And now, given you have populated routing table, you can do routing, and you can do routing from the most accurate source to the most accurate destination because you have host routes behind the respective VTAP. So when you do this, host A to host F, you follow the host route information you got as part of EVPN, as part of the installing of the forwarding table. And respectively, in the other direction, you do the same. Question, does this routing look very different than what we just did before with the external world? Not much, right? We're using routing table information, we're using IP information because all of this was routing. There was a question.
Yes. Let's suppose that I have that subnet, one dot something, only on that leaf.
Yes.
Can I suppress type 2 routes and should I?
Yes, okay. Question is, if I have the subnet only on one leaf switch, do I really need to advertise host routes? No, you don't. Because the next question is, do I really need to extend layer 2 at that point? And the answer is no. So your VLAN has no VNI. And respectively, you will not advertise a route type 2. And respectively, you will not have a host route. So absolutely, you can do this. Not a problem at all. So now, we had routing, right? We were all talking about routing. Now we go in bridging. And yes, I know, it's a roller coaster ride. But come on, you guys are the champions here. I know I go fast. But let's see if we can wrap that up actually with a little bit more time towards the silent host discovery, because that's when everything comes together, which we talk in the first 3 packet walks. Topology, still the same, and we do a layer 2 packet walk. So we do bridging now. So my source MAC address of host C and my destination MAC address of host E has to be fully transparent all the time, right? I don't want to change them, I don't want to alter them, they have to be there. I want to have true bridging, no change in source MAC or whatever else in my packets as I go forward with this. So again, we have a learning phase, which is I have to learn the respective MAC address locally on a port. Here we have host E connected to L4. And to be very, very specific, if you just want to do layer 2, there's no need for an SVI. There's no need for an IP VRF. Generally, you do routing and bridging in these cases, and that's why I always bring you the VRF, which I always bring you the SVI, which I always bring you the IP VRF and the MAC VRF in combination. So you see here, I learned the respective host there locally on that port. I have pre-configured the IP VRF, the SVIs, as well as the MAC VRF, the VLAN in that case for VNI mapping. And I learned that host as a route type 2 and complete the MAC and IP information in there. You can see on top the 100E, which is host E's MAC address, and you see 1.55, which is host E's IP address. So it ARPed. Priorly, we have an entry in the ARP table, so we will forward that route type 2, that MAC IP route complete for routing and bridging purposes. As we receive this, we populate the MAC table for VLAN 10. VNI 30,001 is mapped to VLAN 10. Could be mapped to something else, but I'll just use VLAN 10 in this case. And we will have this MAC address with a next hop of an IP address, which is quite unusual because most of the egress interface you will see in a MAC table are actually Ethernet interfaces or port channels or the like. You normally don't see a next hop IP. In VXLAN, you will see a next hop IP. So here it goes. We also install the host IP of host E. And then we do the same in reverse. We have a port active for that VLAN. The host C is in that VLAN. We advertise at type 2 with the MAC and IP information. We install these information in the MAC table and respectively in the VRF table and have now a converged forwarding table in L3 and a converged forwarding table in L4. So what are we doing now? Are we doing routing again? No, we don't. So, given that my source MAC is 100C, which is host C, my destination MAC is not the gateway MAC anymore. It's 100E. It's the remote which we learned from over there. We will not talk to the router itself or the first hop gateway or the default gateway. We'll talk directly to host E, so we do bridging from that point on. No IP lookups happening in that case from a L3 perspective, from a forwarding perspective towards leaf 4. Now, here we have to do the encapsulation. And the encapsulation, we need actually that next hop IP information of the MAC table, which tells me who is that VTAP I have to send it to. Right? So we add the SIP and the DIP as well as the VNI, the front portion to this, the source MAC and the destination MAC, as well as the SIP and the DIP, the source IP and destination IP in the inner, is not going to change. You guys are good with this? This is classic MAC forwarding, right? Or bridging in that case. So source IP is leaf 3 IP, which is its VTAP IP address. Leaf 4 IP is the leaf's 4 VTAP IP address. So between the two, we will do encapsulation. As we hit leaf 4, we remove the VXLAN headers and just make it a normal Ethernet frame. So these are the classic encap, decap processes you would do on an ingress and on an egress VTAP in the case of bridging. So no changes to MAC at all. There's a question over there. That's a scenario where ARP suppression doesn't work. Well, yes, because there is no ARP in that case from a switch perspective, right? We would not know that there is anyone need to learn ARP. We're just doing layer 2. ARP would be there as soon as we have MAC IP, right? As soon as we need to learn an ARP entry of the host, at that point we would have ARP suppression there because we need to proxy these infos and learn them first before just going on a wild goose chase and start proxying in a layer 2 network, which can be very difficult at that point, right? If ARP suppression is enabled on a layer 2 segment only, that would be generally an unsupported case. You would need an SVI in the case. That's when ARP suppression can come in and help you. So in the case, we go reverse, host E to host C. So again, bridging case, let's say that's the return traffic from host C to host E. Now E answers to this. MAC addresses stay the same all the way through the path, and you see the SIP address is the leaf 4 VTAP IP address, and the DIP address is the leaf 3 IP address. The VNI is 30,001, source MAC and destination MAC and IP is unchanged in this case. Was that more difficult than the routing one? You guys are good? You guys are tired? I am. So next part is BUM. And in BUM, there is not really much to say. I mean, BUM, broadcast, unknown unicast, multicast. We go with the same topology, but now we have 2 different ways on how to do BUM. And if BUM is not good enough, broadcast, unknown unicast, multicast, I just re-emphasize it. We have BUM with ingress replication. That's one way of doing it. Ingress replication or head-end replication is the same terminology or same thing. And it means that whoever hosts, let me try to say it better. The host sends a broadcast to its first hop switch, to its leaf where it's connected to. That leaf is what we call the ingress VTAP. That leaf is responsible to replicate. So however many VTAPs you have in the network which participates in that same VLAN/VNI, poor leaf 1 has to do all the work to send that broadcast on a unicast or multicast packet to leaf 2, leaf 3, leaf 4, and whatever, how many you have. So here's the poor guy who needs to replicate. What does it mean? It's a multiplication of packets, so your link between leaf 1 and spine has not just the packet 1 sense, meaning the broadcast in that case, it has a 3 times sense in this kind of scenario. How are we doing this? We have a learning method there. We have the VLANs configured on all of them. We have the VNIs configured. We have a MAC VRF configured. That gives us a route target. And now we know that leaf 1, leaf 2, leaf 3, and leaf 4 participate in the same layer 2 segment. If this is configured with ingress replication or IR, we will advertise what is called route type 3, which advertises its capability of sending or receiving bump traffic in a unicast tunnel. And you see these here, they basically tell you it's per VNI, so the label is there, you have the route target to say in which MAC VRF needs to be installed, and you see the next hops. And this is how we build a flood list, right? This is the information to build the flood list. This is control plane. This EVPN will not replicate anything. This is just control plane to tell who participates in that flood list, and then respectively we build a flood list on leaf 1 and saying L2, L3, L4, we need to flood to VNI 30,001 whenever there's a broadcast on a unicast, multicast coming in. And respectively, given all of the other 3 leaves also participate in that same VLAN, they also build a flood list. And now you can see where the ingress replication is coming from. Wherever a packet goes ingress to L1 or ingress to L2, L3, L4 from a bump perspective, we need to replicate it to all of my other members in the flood list. If you don't do that, Ethernet will be impaired because EVPN, VXLAN, is a layer 2 encapsulation. It follows the Ethernet flood and learn semantics flood semantics from a broadcast onion unicast multicast perspective. So this is how we built these overlay tunnels in that case. To emphasize my point, host A sends a bump, whatever it is, could be ARP, doesn't need to be. L1 has the flood list and will replicate to leaf 2, leaf 3, leaf 4, so it will send 3 times the same bump packet in that case, encapsulated in VXLAN. You see here, I don't know if this is a layer 2 broadcast or a layer 3 broadcast. I just took all Fs and all 255s in there. Could be either or, as we do full support of MAC only as well as MAC IP in these cases. Now, as all the leaves receive it, they will decapsulate it. We will remove the outer headers, the VXLAN part of it, and then we will just perform nothing different than either a MAC broadcast or an IP broadcast in the local VLAN segment where we decided to replicate to. Yes?
A more fundamental question. So how did all the VTAP find a common route reflector in EVPN?
Okay. How does the VTAPs find a common route reflector? It's by configuration. Router BGP, neighbor IP address of the route reflector, you point there. On the route reflector, it's neighbor IP address, and then you say route reflector client is that given node. So traditional BGP in that case. Static configuration. We have some knobs in order to simplify things like prefix routing, prefix neighborship or unnumbered peering, but probably have to discuss that a little bit offline on that point. But yes, we do have ways of doing this. Now, given we have 2 modes, I want to also give you the topology overview and again the bump packet walk with multicast. Again, remember, EVPN doesn't replicate. EVPN is the control plane protocol which tells you about something. If you don't need to know about something because somebody else takes care, then somebody else takes care. In this case, in multicast, PIM takes care of some of these pieces. We're talking here underlay PIM and not overlay PIM, right? So we have again this topology, and when we do a BUM replication with multicast, L1 is relaxed because it just has to say, send it to some group address, go away. And then the next top router in the topology will say, okay, I'm part of multicast. I will replicate it on all of my interfaces where I have a possible receiver in that tree, right? Or part of that tree. So in this case, it's my spine. So when we say leaf spine, leaf 1 goes to spine, 1 packet, spine replicates it and sends 1 packet at a time down to leaf 2, leaf 3, leaf 4. So when you see this here, no multiplication of packet. It's your choice, what do you use? We have ingress replication, we have multicast. It's literally your choice what you feel more comfortable to do, but I need to tell you that there are 2 ways and what is the difference of it. So in this case here, we again have VNI 30001 participation of all these 4 VTAPs, and we now do a configuration on all of these switches and all of these VTAPs, which says VNI 30001 participated multicast group 239111. And as you can see, the configuration is symmetric on all of them. So again, this is a configuration you do. Before you say, I want to use ingress replication protocol BGP, which enables EVPN to distribute the route type 3s. Here, EVPN doesn't have to do anything because we do PIM joins at that point in the underlay. So we create another flood list, but the flood list now just says replicate it to the 239111. Let multicast deal with this strange BUM packet. I don't want to care about it as my leaf 1. So when we do this in a very simplified way, leaf 1 is the source of a tree, leaf 2 is a source of a tree, leaf 3 is a source of a tree, leaf 4 is a source of a tree. Because all of them could send a BUM packet, right? So in fact, it's not 1 tree, it's actually 4 trees you're having here in this case, and they are built with different sources at that point. So here we have, again, either a layer 2 or a layer 3 broadcast packet. We send it to layer frame or packet. We send it to leaf 1. Leaf 1 knows VNI 30001 multicast group 239111. So when we built that encapsulation, when we built that packet, source IP is L1 IP, destination IP is multicast group. What happens as a result of that? We send it to the spine sees, oh, it's multicast, follow the tree, send it to leaf 2, leaf 3, leaf 4, or maybe there's another topology which is extended and you have another single hop and then fan out further out. The important is as it hits the leaf, as we do the decapsulation, we remove the outer header, we remove the multicast related and VXLAN related pieces and make it again a traditional Ethernet frame, sending it out on the VLAN segment where we were intent to based on the VNI to VLAN mapping. Yes, sir.
What type of route is this?
EVPN, what type of route is this? There is no route in EVPN. This is PIM, underlay multicast. There is no EVPN involved here. The only thing what you have is you tell my VNI is associated to a multicast group, so my flood list is a multicast group. Ingress replication has a route type 3. I could go in a little bit more details that there is a route type 3 which could signal multicast groups. I don't want to go there because the use case is not exactly this here, but for a fact, this is no EVPN route here when we do the multicast piece for underlay broadcast. It could be a route type 3, but you don't need to use it as per the RFC definition. It's optional to do. Now, we did layer 3, right? We did layer 2, we did BUM. This here puts all of it together. So I will go a little bit slower. A little bit. I know I speak fast, but I will go a little bit slower on this one here. As when you understand this here, you understand all of the rest. So it's a repetition piece we're doing here. I'm trying to build on top of these previous ones. And even as you might have a gap in one of the previous ones because I was speaking too fast, you will see it here again coming in. We have all these hosts, same topology. So when you go through the slide, it's always the same topology. I'm just choosing to use different sources and destinations. And when you look at the MAC addresses, you will always see the host notation is actually the MAC address coming up there. So ABCD, etc., as well as the IP addresses are just counted through like 22, 33, 44, etc. So now we have a host in that network which is silent. What is a silent host? Maybe it's a host who never ARPed. Or it's a host where we have, for whatever reason, ARP expired. Maybe it went to a dormant state, didn't refresh themselves. So we never heard of that from an IP layer perspective. Now, when this is a silent host from an IP layer perspective, can we route towards that host? We actually can't, right? So when we look here at host A in one subnet wants to talk to host D, we don't know where host D is. What are we going to do? We need to do some flooding, right? So bear with me. So we have host D. What we know of host D is it's somewhere connected. We don't even know if it's connected to L3, to be very honest, right? Because it's dormant. So the best thing we have as a navigation point of where host D could be is it could be in a layer 2 segment, yellow. It could be in the IPVRF. It could. We don't know. It's dormant, right? Silent. But what we know is the segment yellow, VLAN based or layer 2 based as well as layer 3 based is configured on L3. We know that. You guys agree? I have an SVI, I have a VLAN. The SVI there, we said we want to advertise the subnet route, so you at least know that that yellow segment, L2 or L3, is present on my leaf 3. You guys agree? Everyone agrees? Yes? But it's also on leaf 4. Do we now know where is host D? No. It could be on L3 or L4, right? Again, it's dormant. We don't know. We only know that the subnet where host D should reside in, which we want to talk to, sits in either of them. So given that, we create at least a routing entry of 192.168.20/24, and L3 and L4 is our next hop in that case. So we would have equal cost multipath at that point. Now, if we do this and we send something, so 111 to 244, because host A doesn't know that host D is dormant. It's just a network who thinks it's dormant. Still, it's destination IP. It would know. He wants to talk to him, ping, for example, if he wants. So we would hit leaf 1. Leaf 1 would say, hey, I don't know 244, but I know 2.0. And if you want to go to 2.0, it could be L3 or L4. By the way, I decide, based on my hash, I'll send you to L4. Again, remember, host D is silent. We don't know where he sits. So we hit leaf 4. Is that a good thing? We don't know the host is there, right? We literally don't know. We just did a guess based on subnet routing, type 5 routing. So we decapsulate, and what we get is a miss, right? We cannot deliver it. There is no table entry for ARP, right? And given that we want routing, we need to have the MAC IP binding towards that local segment there. So if there is a miss, we have a process. Actually, it's not just a process, it's actually exactly what it means. It's glean. Go and glean where host D is. Go and wake him up. Anyone has a clue how we can wake up a host and force him to do ARP? It's not GARP. GARP you can just ignore if you want as a host. But what you can't ignore is a unicast ARP. When I go specifically, not a unicast ARP, so let me be very specific. An ARP request to your IP address, you have to always respond. So what I do as part of this glean process, I send out an ARP request. I send out an ARP request in my bump tree, could be ingress replication, by the way, I just choose to use multicast. So I send it to the spine. Spine will multiply that packet to all the switches which are having the yellow segment present. Now this is layer 2, right? This goes bump. Before we want to route it to host D, now in order to find them, we need to ARP, and that is a broadcast, so it becomes a layer 2. So it goes to spine. Spine sends it to L3 because L3 is part of that yellow segment of that VLAN, I think it's 20, and it will send that ARP request as a broadcast out on the VLAN segment, and host D will receive that ARP request. He is forced to respond to that ARP request. A host must respond to an ARP request. ARP response, unicast. Let me show you one trick we do. Do you see the inner source MAC of our GLEAN request? 2020.0.0.0 AAA. Distributed IP Anycast gateway. So the first hop gateway for segment 1 has this gateway MAC address. So leaf 4 and leaf 3 have not only the same IP address as a default gateway, which would be, can't see it here, no, 2.1. It also has the same MAC address. So request is being sent out. Response goes respectively, because the source was the Anycast gateway MAC, to L3. Why? Because the DMAC is the distributed Anycast gateway MAC. Hey, you talk to the DMAC, right? ARP response. What does happen now is, you remember when I said we learned the host based on ARP? Boom. Good morning, host D. You're there, I can see you. I previously had my VRF tables. Now I have actually much more information. Let me send you that route type 2 with my MAC IP information. Great, right? We woke him up. And now subsequently, I can populate that 244 is behind leaf 3. And every subsequent routing can happen based on now a most accurate host IP address with its destination. So not anymore blurry with L3, L4. I might go to the right or I might not. I'm going to the right leaf where host D, previously woken up by me by an ARP request through that GLEAN process behind leaf 3. And from here on, I encapsulate towards leaf 3 as the STIP address and will be able to talk to host D. Now, during the GLEAN process, you will have something which is called unknown unicast flooding for a very brief period of time till GLEAN has been completed. Generally, you will not see silent hosts in EVPN. If a host has been once learned, we will refresh that host periodically before the ARP entry on the SVI expires. And I will try and retry. So if you might still be here, you ARPed once, 2 hours ago, I might just say, hey, are you still here? Unicast ARP, tell me. And I refresh. And that's what we call an active gateway or a distributed Anycast gateway. And that's why it never, or close to never, has an unknown unicast event in VXLAN EVPN. And when it exists for a very brief period of time. I know it was a lot. You have the slides. You can go step by step through every piece of the diagrams. I haven't seen a typo yet. Let me know if there is a typo. I'm very receptive for feedback. But conclusion is, I gave you a whole bunch of a roller coaster rides. Do you guys have enough packet walks? If not, just wait a little bit. Max is ready for the multi-site one. Host to external, host to host, routed. We did host to host, same subnet, bridged. We did BUM, and we did silent host discovery. These are the most critical packet walks you need to understand for operation of VXLAN EVPN network. With this, be gentle to me. It's the first time I do this. Well, this session. I know it's a lot of content. Session survey, please, if you guys can. Learn, train, certify. I know the day is short. Have a coffee and relax, and I see you somewhere else or maybe up here. If you have some additional questions, I will be here for a little bit and talk to you guys. With this, thank you very much. Thanks for hanging in there for a couple of more minutes. Thanks.